Okay, third example. We've got an ice hockey puck of mass 0.17 kilograms, receives an impulse of q. Immediate before, velocity is 10.5. Immediately after, it's 15 minus 7. And we want the magnitude of q and the angle between q and I. So, yeah, I don't think it's anything too complicated here, but I'll go through it anyway. So, impulse q, which is technically a vector, is equal to mv. So that's 15 minus 7 minus mu. You can combine that together if you want. Just don't think about it while I was writing it out. You can pretty much work that through your calculator. That gives you 0.85 and negative 2.04. And then the magnitude of q, so we can write that like so. You're sort of taking a positive value, so it kind of fits in with the modulus symbol, but this is magnitude of q. And then that's just Pythagoras on this vector. So 0.85 squared. You don't need to put the negative in here because you're squaring it. And then the magnitude comes out as being 2.21. And then we want to find the angle between Q and I. I would suggest you just sketch these just to make sure you do the right thing with it. So you've got 0.85, negative 2.04. Down here. And we want the angle between Q and I. So we're looking for this angle here. And so tan theta is equal to opposite, which is 2.04 over adjacent 0.85. And then theta is arctan of that, and you end up with 67.4 degrees. Okay, so it's just, I mean, it really is what we were doing before, but just putting some vectors in. And then last example, it's just a little bit of momentum. So a particle of mass 0.15 is moving with velocity 20 minus 10 when it collides with another particle, 0.25 kg, moving with velocity 16 minus 8. The two particles coalesce and form one particle, and we want to find the velocity of the combined particle. So this is just conservation of momentum. So if you remember, you can lose some kinetic energy on an impact, but momentum is always conserved. So momentum before sorry, I've got my 0.25. Equals momentum afterwards. So if they coalesce, the combined mass is going to be 0.4. And then we're looking for this velocity. Just try and underline your vectors if you can. It's easy to forget, and you won't get penalised for it, but yeah, it's worth remembering. If you combine this lot together, you end up with 0.4v is equal to 7 minus 3.5. And then dividing through by 0.4 gives you v equals 17.5 negative 8.75. So all I really want you to do today is just do some work on that. These questions will get harder, so this is kind of going into the harder end of mechanics. So we'll keep it nice and straightforward today, and then we'll start moving into the collisions first thing tomorrow.